water. Remember, number esterification reaction also we take off water, right? Ethanol plus, what is the other reactant? Ethanol plus acetic acid gives you ethyl acetate plus water. So adhe you can now take this deoxyribose CH2OH, react it with phosphoric acid, and then remove the water, and then you get a phosphate, right? So this is an inorganic phosphate. For example, it is known, actually, if you go, you can, chemistry wise, you can actually get triethyl phosphate. Okay, you can buy it from, so what is triethyl phosphate? All this H, all these three H's are replaced by ethyl groups, right? So OCH2, CH3, OCH2, CH3, OCH2, CH. So we can call it triethyl phosphate. So this is, so now this is a, now you can see what is the name of this compound. So this is called a nucleotide. So what is the name of this compound? How shall we name it? Now we have to name it to take into account all the three parts of the molecule. So we will first take deoxy adenine, right? So we will say this sugar is the same everywhere, right? So this is going to be deoxy. This is going to be different. How many types of bases do we have? Four, right? Right? Adenine, thymine, guanine, and cytosine. So we will see that this is deoxyribose, adenine, right? So adenine, deoxyribose. Because of the P is phosphate, M is monophosphate. So this is how we will name it, right? We will call it deoxyribose adenine monophosphate, right? So this is a nucleotide. So we will go to the next thing. So each of our DNA, right, contains this. This is our basic material, right? Next is we have to, our DNA is a huge molecule, right? So how is this chemistry? In the chemistry and in the groups how can you make a huge DNA molecule, right? In the molecule we cannot have all the information for such a complex being. So so we can do another chemistry. What can we do this another chemistry? Chemistry from a small molecule, if I want to make a big molecule, polymerize. Very good. So you make use of polymerization. What is the essential condition for polymerization? Okay, we have to make chains. That is, there should be at both the ends of the molecule. At both the ends of the molecule, you should have a double bond. Very good. So you should have a reactive group. Are you able to follow? Both the ends of the molecule, you should have a reactive group. As he very rightly said, a double bond will make that. If example of a polymer with double bonds, polyethylene. The soles of the shoes and chappals enough use for that. No, you can't use polyethylene, right? It will rub off very fast. Or do you use very hard material? What is it called? Velcro is there. In the soles, polystyrene. Have you heard of that? Polystyrene. Don't worry too much about it. Polystyrene the CH2 polyethylene CH2 double bond CH2. So one of the hydrogens might become phenyl. Benzene ring that is polystyrene. one of the hydrogens you take. So phenyl or benzene, CH, double bond, CH. This poly. So the essential part for any polymerization reaction is that it should have two double bonds, two reactive groups. Double bonds support on. Okay. It has to that two in the same molecule, in the same atom which is bonded, right? There should be two reactive groups. So the number in the compound in this compound, don't think about do we have in any part of this molecule two reactive groups? No one. எல்லாருக்கும் புரியுதா question? எல்லாருக்கும் புரியுதா question? இந்த moleculeல வந்துட்டு ஏதாவது இந்த இதுல two reactive groups இருக்கா ஒரே molecule? Yes sir. Very good. In the oxygen, O minus can react with another OH of the other sugar. Correct? Very good. Excellent. So now you got it. So this is exactly what it does. So you came there. So you have the CH2OH here. This reacts with this oxygen. There is another OH here that reacts with this. So this goes on building. So we can easily make that. That is in the CH2OH. This is that CH2OH. Ingo oxygen. This oxygen can react with this OH. Correct? And then we can make this CO. So we can make a polymer. So polyethylene how many monomeric units are there? Two. No. Two reactive that N CH single bond CH single bond CH single bond other on the end of protocol. What is that N? How much is it for polyethylene? About 100,000. That N is equal to 100,000. So that is correct, yeah, because ethylene is a gas, but polyethylene is a solid, right? So you have to have large. So very similar to that. What is N in our DNA? Are you able to understand the question? No? Okay. So now we have said that this is the monomeric unit, right? This is the monomeric unit. This is the polymeric unit. That is goes on repeating. Only thing that will be different is the base. The bases will be different, right? All others will be everything is the same. In our DNA, the bases are different, right? So how many such polymeric monomers will for example, we said CH single bond CH is N times that is 100,000. This thing goes on repeating, right? So this N is going to be our DNA. Right? That is N is going to be. So how much is N for DNA? 1 trillion. 1 trillion is the number of cells. DNA it is actually 3.5 billion. Okay, this N. So you know that this goes on repeating, right? And this is going to be, this N is equal to 3.5 billion. Now you just note it down. We will use it later on for some calculation. So this N is equal to 3.5 billion, right? So what can we say? That our DNA is made up of 3.5 billion bases. Correct? Because only it is not constant. Right? Only this will be different. Right? So we will say that our DNA is made up of 3.5 billion bases.